We spent the last day and a half now talking mathematically about impulse. Today I want to talk a little bit about a more conceptual aspect of impulse. What exactly does impulse explain for us? Like, where exactly do we, besides a mathematical approach, apply impulse in the real world? Well, there are two general scenarios. What I call a predetermined impulse. A predetermined impulse is when we're stopping an object. Now, just put down your pens for a second and listen carefully to what I'm about to say. If I'm driving a car down the road at 100 kilometers per hour, my mass is fixed, right? Like maybe the mass of me in my car is, let's say, 2,000 kilograms, let's say. That's not changing. Now, the velocity of me in my car might be 100 kilometers per hour. We know what my momentum is right now. We know what my momentum will be eventually. Eventually, it will be zero. So we know, no matter how me in my car come to a stop, we know what the change in momentum of me in my car will be. Right? We know it's the final momentum, which is zero, minus the initial momentum, which is the mass times the velocity. So we know what the impulse of that car is going to be. It doesn't matter how it stops, the impulse is going to be the same. I may come to a slow, gradual stop at the first set of lights on the way into Calgary, or I may come to a crashing stop when I hit another car or I hit a concrete wall. Whatever. It doesn't matter in terms of impulse. We know what the impulse is going to be. That's what we call a predetermined impulse. We call it that because the impulse is going to be the same no matter what. It's determined only by the conditions that I have right now, my mass and my velocity. Does that make sense? When we're stopping an object, the impulse will be predetermined. Now, on the other hand, when I'm starting an object, the impulse is not predetermined at all. Okay, maybe there's a baseball in my hand. Okay, I will cause that baseball to start moving when I throw it, right? Maybe that baseball gains a little bit of momentum if I just give it a soft toss. Maybe it gains a lot of momentum if I throw it really hard. A golf ball sitting on a tee. Okay, I can give it a little bit of momentum by just hitting it a bit, or I can give it a lot of momentum. The impulse of the golf ball of the baseball is not predetermined. Even a baseball that's coming towards me, and I swing the bat and hit it, right? I start it moving in the other direction. The impulse is not predetermined. Usually what I want to do is give it more impulse, right, so it goes farther. Make sense? So when you're stopping an object, the impulse is predetermined. When you're starting an object, the impulse is not predetermined. Now, how do we use those two things to explain these situations involving impulse? Well, if the impulse is predetermined, let's say, this is the equation for impulse, right? Or at least that's two parts of the equation for impulse. If the impulse is predetermined, in other words, it's not going up or not going down, and I am able to increase the time that it takes to stop the object, then that's going to decrease the force. Does that make sense? Like let's say the impulse is 10. If I make the time of stopping 2, then what's the force going to be? It's going to be 5, right? 5 times 2 is 10. Does that make sense? But let's say now the impulse is, well, 10 again, because it's predetermined. No matter how it stops, it's going to be 10 for this particular object. But I increase the time now to 4 seconds. What's the force going to be? What's the force going to be now? 2.5. So what I've done is increase the time, and the effect of that is to decrease the force. This is really, really important because this is the answer to one of your diploma exam questions, or at least almost certainly one of your diploma exam questions. Now, that question may be phrased in any one of a million different ways. The bottom line is, you're likely to get a question that talks about cushioning an impact. Maybe it's, why do we have an airbag in a car? Well, to cushion an impact, right? Why does a goalie have goalie pads? Well, to cushion an impact. Why do you, when you jump off of your desk, like this, why do you bend your knees when you land? Well, to cushion an impact, right? Why, when you catch a baseball, do you kind of cradle the baseball a little bit like this instead of just sticking your arm out rigidly like this? Well, to cushion an impact, right? Whenever the question involves cushioning an impact, the idea is always to increase the time that it takes to stop. Why do I bend my knees? Because it takes me longer to stop, which decreases the force on my knees. It's not impulse that hurts my knees. It's force that hurts my knees. Let's increase the time that it takes to stop to decrease the force on my knees. Let's increase the time that it takes to stop the baseball to decrease the force on my hand. Let's increase the time that it takes to stop your head in a collision via an airbag to decrease the force on your head. Let's increase the time that it takes to stop a hockey puck using goalie pads to decrease the force. Does that make sense? Whenever you're cushioning an impact, you're increasing the stopping time, and the effect of that is to decrease the force. Now, there is another principle at play sometimes, okay, with goalie pads or a football helmet or something like that. Not only does it increase the stopping time to decrease the force, but it also spreads the force over a bigger area as well, right? That's not what we're looking at here, but understand that what we are looking at, the impulse thing, is always relevant. But sometimes there's something else relevant as well, like the idea of spreading the force over a bigger area. We won't worry so much about that, though. All right, make sense? When you're stopping an object, the impulse is predetermined, and the idea is that you want to increase the time that it takes to stop to decrease the force. Usually, at least. It's conceivable, I suppose, that you might want to increase the force. And in that case, you decrease the time, the stopping time, right? All right. Now, the other situation is when we have a non-predetermined impulse. This is when we're starting an object, the golf ball on the tee, the baseball coming towards me from the pitcher, I swing the bat and hit it. The basketball that's in my hand as I'm about to throw it towards the net, shoot it towards the net. When you're starting an object, the impulse is not predetermined. So what happens here? Well, usually what we want to do is increase the force. What effect does that have? It's not going to decrease the time. It's going to increase impulse. If you increase the time of contact, then you're also going to increase the impulse. Listen, if I want to hit a golf ball farther, it's sitting on a tee and I want to hit it farther, what do I got to do? Well, I want to hit it harder, right? Apply a bigger force. It's going to go faster, more impulse, therefore go farther. What else do I want to do? I want to have good form. I want to follow through. Okay, you don't see good golfers hitting a ball like this. They follow through, right? Baseball players, same thing, right? They follow through. Hockey players follow through, right? Why do they do that? Because as you follow through, it increases the time of contact, between the puck and the stick, or the club and the ball, or the baseball bat and the ball, increases the time of contact, which doesn't do anything to force. Not here, not in number 2. It just increases the impulse. So back here with number 1, when we're stopping an object, we say that time affects force. Increase time, decrease force. Down here, when we're starting an object, time and force don't affect each other. Here we say time affects what? Time affects impulse. And so does force. So in the first situation, force doesn't affect impulse, time doesn't affect impulse, force and time affect each other. In the second situation, time and force don't affect each other at all. Time and force both affect, independently, the impulse.